Right. Hello, students. This is Mr. Allen, your geometry teacher, and today we are going to continue our discussion of congruent shapes. Specifically, we're going to talk about congruent triangles and how to prove that they are congruent. So as you can see here, I have two triangles. It turns out that they are congruent. They are the exact same shape and the exact same size. Now, the orientation of them is different, but these two triangles are actually congruent. Our objective today is to prove two triangles are congruent using one of the following theorems or postulates: SSS, which stands for side, 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 and I probably should tell you that right out the gate. This stands for side, side, side. And then the next one stands for side, angle, side. And then the next one stands for angle, side, angle. And my guess is you're catching a trend here. So SSS stands for side, side, side. SAS stands for side, angle, side. So these are ways that we're going to be able to prove that two triangles are congruent. So last week when we looked at section 4.1, we looked at this definition. This is how we proved that two polygons were congruent. We showed that all their corresponding sides are congruent to all of their corresponding, and all of their corresponding angles are congruent. Now we're talking specifically about triangles, and we can't quite see that there, but so how many corresponding sides do triangles have? Well, they're going to have each three sides, so three corresponding sides, three pairs of corresponding sides. How many corresponding angles? Well, there's three pair of corresponding angles. In other words, what I'm trying to say is if we wanted to use this definition to prove that two triangles were congruent, we would have to prove 6 things for each pair of triangles. 3 corresponding sides and 3 corresponding angles would all have to be congruent in order to use this definition. That's a lot of work. I claim that after today, we'll be able to cut that work in half. In other words, we only need to show 3 things are congruent. And here they are. And notice I said this is summary too soon. Here's those 4 postulates, theorems that I mentioned, and these are visuals. So what I'm telling you is this. For example, let's look at this one right here. Let's look at SAS. I am telling you that if you have 2 triangles where one side is congruent to another side, a second side is congruent to a second side, and then this angle here is congruent to that angle there, then those 2 triangles are congruent. You only have to prove 3 pairs of things. In this case, 2 sides are corresponding and congruent, and then 1 pair of angles is corresponding and congruent. Over here, SSS, you have to just show that all 3 corresponding sides are congruent. For example, down here, AAS, which by the way is a little bit different than this one, you show 2 angles and a non-included side are congruent. And I'll talk about all of those things. But it's unusual to do this in teaching, but I'm actually going to start with the summary of what we're going to do. So let's start with the first 2, and then we'll get to the second 2 later. Now, notice, first of all, both of these things are postulates. So the first one is the SSS postulate, and it says if 3 sides, so here it is in words, if 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. So remember, this is P arrow Q. So if you've got these 2 triangles, and you know all those corresponding sides are congruent, you can conclude that the triangles are congruent. In other words, they're exactly the same shape and the same size. Now, this second postulate's a little bit different because we've got, instead of 3 sides, it's 2 sides and then the A. Notice that the A is in the middle, and I want to bring your attention to your notes to the words included angle. So if I have this side is congruent to this side on the triangle, and then I have that this side is congruent to this side of the 2 triangles, then it has to be, not possibly, it has to be the included angle. In other words, it's the angle that's formed by those 2 sides. That's the only way that you're allowed to use this theorem. If the angle was not included, you cannot say the 2 triangles are congruent. So let's see an example of this. So here I've got Actually, there's 3 triangles drawn here, but we're going to look specifically at the 2 smaller ones. Hopefully you can see those, and we're going to do a proof. I want to try to prove that triangle XYV, that's XYV, that's this triangle. I want to prove that that triangle is congruent to triangle WYV. Okay, that's what we want to try to prove here. So I've already got the proof set up. We just got to fill in the blanks. Now it's going to be either, telling you right now, it's either going to be SSS or it's going to be SAS. I'm not telling you which one, but it's one of those 2. So let's see if we can work it out. So the given information, well, let's just start with the first step. The first step says the statement Y bisects XW. So that's this here. So Y, okay, so point Y bisects XW. Well, that's given. So that's, remember, I've been trying to work with you guys on this. Usually the first step is always given. So that's given. Now, step 2 says the reason is definition of segment bisector. So if Y, it bisects segment XW, then that must mean that XY segment is congruent to WY. Okay, that's a Y, sorry. In other words, this segment has to be congruent to this segment. If Y is a segment bisector, that means it divides that segment into 2 congruent segments. Okay, cool. So by the way, I would note that that's a side congruent to a side. Step 3 is given. Well, we already used this given in step 1, so it must be this part is the second given, so that means that XV is congruent to VW. So that's given. Okay, great, and that's already marked. We can already see that that's been marked on here. Step 4 says that YV is congruent to YV. That's interesting. Why is it that this would be congruent to its, oh yeah, that's the what property? Reflexive property. Reflexive property. Reflexive property says that something is equal to itself or something is congruent to itself. So now I think it's clear, isn't it, that this is going to be true by SSS. So the answer for 5 is the SSS postulate. And what do we got to put in for the statement? Well, the last statement always has to be whatever it is that we're trying to prove. So triangle XYV is congruent to triangle WYV. So there's our proof, and it's completed. I have now proven that these 2 triangles are congruent, and I only had to prove that one side was congruent to another side, a second side was congruent to another side, and then the third side was congruent. So I used the SSS congruence postulate. So now in example 2, I would encourage you to pause this one and try to figure out which of these can be proven congruent using SSS or SAS. If there's not enough information, write not enough information and then be able to explain your answer. Pause. I'm not going to pause, but I would encourage you to pause and just look at these and just take a guess. There's 3 of them, A, B, and C. Okay, so here I go. So for A, I can see that one side is congruent to one side. A second side is congruent to a second side. And it looks like that's that included angle. It's congruent to an included angle. So I'm going to say, yes, these 2 guys are congruent by SAS. This is by SAS, side, angle, side. How about B? Well, let's see here. B, I have, let's do a different color. I've got a side congruent to a side, a second side congruent to a second side, and then an angle and congruent to another angle. So that's got to be not enough information. Here's why. This is very important. I hope you caught this. This is not an included angle. Since that angle is not included, you cannot determine that these 2 triangles are congruent. All right, so hopefully you got those 2 right. So this one's not enough information. Question A was yes by SAS. question C, I think, is this pretty straightforward one. Why are those two triangles congruent? Well, clearly it's going to be by side, side, side. That's probably the easiest one to see. All right, let's look at the other two postulates. I got to be careful. This technically, I should not have written postulate here because this second one is actually a theorem. All right, so here's what it says. The ASA postulate, which basically sounds a lot like SAS but backwards, or the letters transposed. So what we're saying here is if we have an angle congruent to an angle, another angle congruent to another angle, and then the included side, that would be the side that is in common with those two angles, then the two triangles are congruent. Now the AAS postulate's a little bit different. In fact, it's not even a postulate. Again, I'll emphasize this is actually a theorem. And the reason it's a theorem is because we can prove it. And I'm going to kind of leave this one alone. But first of all, I want to differentiate the two postulates. This one here, this AAS, the angle is not include. I'm sorry, the two angles, and then the side is not included. I'm going to erase all my writing here for a second. So this one again is a theorem. Okay. Oops. But this particular one on the right, this guy, this one, notice that the side is not the side in common with the two angles. So that's how they differ. ASA, the side has to be included. But in this one, it does not have to be included. Now, the last thing I want to say before I move on to the next, the reason that this one is a theorem, I'll give you a hint. If two angles and two triangles are congruent, what can we conclude about the third angle? That's a review from chapter 3. Actually, I'm sorry, that's a review from section 4.1. All right, let's look at another proof. And I did the first proof, and I would encourage you again to stop this video and see if you can prove this on your own. I'm not going to stop, but I would encourage you to stop it and see if you can complete the proof on your own. So here's what we're trying to do. We've got this shape over here, and they give us some given information, and they want us to prove that the triangle WMR is congruent to triangle RKW. All right, let's see if we can figure this out. I'm going to just use the proof to kind of get me going here, since it's a skeleton of a proof. So I've got that those two lines are parallel. That was given, so that's easy. Oops, given, if I can spell given. By the way, remember that these little extra arrows there, that means parallel. Now, step 2 says the reason is given alternate interior angles are theorem. Alternate interior. Okay, so alternate interior angles theorem. So if we think of this as the transversal, and then these two lines are parallel, then we would say that this angle is congruent to this angle. Those are alternate interior angles. So I'm going to call that, let's see if I can name that correctly, MWR, angle MWR is congruent MWR. So that's going to be KRW. KRW. Those two triangles are congruent. I'm sorry, those two angles are congruent by the alternate interior angle theorem. Step 3, I just gave that one to you. I said that angle M is congruent to angle K, so that's given. Great. So far I have an angle congruent to an angle. Step 4 says reflexive property. Oh, yeah. So, do you guys see this side here? Would you agree that that side's in both triangles? So I could say that segment WR is congruent to segment WR, and that's by the reflexive property. Okay, so now I've got this segment's congruent to itself, so I know that the last step has to be triangle WMR is congruent to triangle RKW, but now I got to figure out, is this ASA or is this AAS? Remember, this first one, it has to be the included side. The side has to be included. So if I look at these two angles, if I look at this angle and that angle, it's not the included side. So it has to be by AAS theorem. Done. Okay, so let's look at a multiple choice example here, and then we've got one more thing we're going to do, and then we'll call it a day. It says, use the diagram at the right. Which of the following statements best represents the answer and justification for the reason is triangle BIF congruent to triangle UTO? Well, let's see what we can figure out. First of all, let's look at option A. It says, yes, the triangles are congruent by ASA. I'd say that's not possible because this side here is not included. So we just talked about that. So it can't be A. B says no. Segment FB and segment OT are not corresponding sides. Not sure about that. Let's look at C. Yes, the triangles are congruent by AAS. Not sure about that. D, no, angle B and angle U are not corresponding angles. So how do we figure this out? We're able to get rid of A really quickly. But here's the thing. If we look at our congruent statement, we know, for example, that angle B has to be congruent to angle U because those are the first letters in each of those things. So I'd say it can't be D. Those would be corresponding angles in those triangles. All right, so now we got to, it's either B or C. By the way, what I'm trying to do here is deliberately show you guys a strategy for attacking a multiple choice question. So let's just check and see if they have to be congruent by AAS. So let's see here. It goes from one angle to two angles to the side. But up here, look, if you go from one angle to the two angle, it doesn't go to the side. So I don't think that's AAS in that regard. I think the answer is B. No, FB and OT are not corresponding sides. In fact, we can double check that if we look. FB is the last and the first, and OT is not the last and the first. So the answer is B. All right, last thing, these are summary questions. I'm actually not even going to go over the answers with you. I'm going to leave these for you to figure out. In question 1, 2, 3, and 4, state if the triangles are congruent, and if they are, why are they congruent? So it's either, again, a summary of what we talked about earlier, SSS, SAS, remember this A is in the middle because it has to be the included angle. ASA, again, this S is in the middle because it has to be the included side. And then AAS. All right, guys, I'm going to call it a day there. Have a good one. Thanks for watching.